welcome back to the Aquifer. I'm Ted Bennett, and in this video I'm going to teach you a little bit about pump curve basics, and in particular we're going to talk about the pump performance curve that you get from your pump manufacturer and the pump system curve, which you as the engineer get to do. So the first thing I want to do is I want to kind of throw it back over to Pipe FLO, and I want to show you what model we've been kind of working off of here. This is the same one that we've been using in this series. It's this submersible pump station where you've got a wet well here and two pumps running as duplex pumps, pumping out of the wet well through some common piping, which combines here to pump through this 8-inch force main. And it discharges up here to this high point. We're calling this an air release. There's some gravity pipe downstream of here that's of greater capacity, so we're ignoring it for the calculation, but 393 at 77 feet of head is what you want to remember. You can graph all this, and they've got some neat export functions on Pipe FLO. So basically, here's the result, but I'm gonna work off of the PowerPoint. It's a little bit easier to read. So here you go. Basically, starting out, you've got your x-axis with flow in gallons per minute. Depending on where your pumps come from, Europe or Japan, somewhere in the world that uses the SI units, you might see some different units down here. Sometimes they'll have 2 or 3 unit sets. Head, usually in feet, sometimes in PSI. Again, you might get those SI units out there. So basically, this is what you're starting with. The blue line, as the engineer, we get to do the system curve, and the shape of this curve is basically a sort of a higher order, I think we call it polynomial. This Q is our variable here. All the rest of this, the C factor, which is the roughness of the pipe, the diameter in inches, and the length of the force main are all constant here. So our flow is the only thing changing. So our head loss is a function of that flow. And so the first thing you're going to want to know on the system curve is the static head. And flipping back to Pipe FLO, you can see our hydraulic grade line that we're pumping to is 676. Just seeing there that you've got a 675 bottom of the tank with a foot of water in it. That's what we're pumping against. And then we're pumping out of a wet well that has 5 feet of water with an elevation of 605. So easy math, 676 minus 605 is 71 feet. That's our static. That's the first thing we need to know. And next thing to know here is we go back to our Hazen-Williams formula, and we take our total head, which we knew, 77 feet, minus our static head to get our dynamic head. So basically this 6 feet is what this is calculating here for the length and diameter and C factor of pipe that we're using. So if this were to increase, if you could pump more, perhaps you would get a number out here with a higher Q. We'll demonstrate all that in some future videos where I'll give you a little bit more on how to do some of this stuff. This is just the basics. So here's your pump performance curve. This is going to come from your manufacturer. A lot of times I try to get these guys to give me Excel spreadsheets or some kind of data set so that I'm not manually punching these in. I remember back in the day we would sit and scale these things with rulers and kind of straight edges, and they never looked very good. You'll do far better if you can get the manufacturer to give you their actual data. So what you're seeing here, first thing to see is the static head, or the shutoff head, I apologize. Up here, this is the maximum amount of head this pump can deliver, but deliver no flow. So basically what would happen here, this would be like pinching a valve shut to basically shut the flow off, and this is what your pressure gauge would be reading downstream. And pumps basically operate like some kind of device trying to push something. Imagine if you had a window open in your house and you were trying to push air out of the window. As you open the window more, you're going to deliver more and more and more flow. So basically that's the way this works here. Looks a lot like a hydrant flow. Also, I talked about that in another video. So the most important thing to get out of this, if you don't get anything else, is the operating point right here. This is where the two intersect. This is the same information that you saw in our pipe flow model. So basically, everything's sort of proven true. This being right from the pipe flow model. Now, one more thing I wanted to show you, just to kind of demonstrate what would happen to that system curve. As the engineer, you're designing these, so you have a lot of control over this aspect. And so let's say that this pipe here that was 8-inch, for some reason it's getting plugged up. Somebody's pushing a lot of flushable wipes down on us. A lot of debris or grease or something is plugging up this force main here, and so now it's operating like a 6-inch pipe for some reason. So now you can see the velocity has changed from before, but we've gone down to 360 gallons a minute at now 88 feet. So that probably makes sense to you, I think. I hope that as you make that pipe smaller, you're fighting against more head. And let me go ahead and just flip this over, and we'll replot this again for the smaller pipe. And as you can see, and let me kind of just flip back and forth here. You can kind of see what happens as that goes. The head increases because the dynamic aspect of that has increased. And what we did is we changed that D on the bottom of that equation, and we made that a bigger number, which makes the head loss change and go up. So take a look at that equation. I hope that makes sense to you. That was the goal, was to kind of show you the impacts of that. And I hope you liked the video. I've really been enjoying putting these together, and I look forward to doing some more of these. I'm pretty active on LinkedIn and Twitter. Enjoy posting things about not only this pump stuff, but a lot of the things that I get to do on a daily basis as a civil engineer working in the water and wastewater municipal aspects of that business. And it's quite enjoyable. I've been enjoying putting these videos together, and I look forward to coming up with some more things to post to you guys here on the Aquifer. And if you have anything you would like to see as far as a video or some kind of question, look me up and send me something. Let's get together sometime. And like always, hey, thanks for watching. I appreciate any positive feedback, and have a great day.